In this chapter, we're going to look more closely at IAM, or Identity and Access Management. IAM is the preferred way to control access to AWS resources. With IAM, each user gets their own set of keys, and if we want to restrict access for a particular user, we can simply restrict or revoke those keys. IAM applies mainly to verbs rather than nouns. What we mean by this is, for example, we could say, allow a user to create a verb, EC2 instances, but not create instances of a certain type, such as larges or smalls. Access can be permanent or short-term. We can give users an expiring account that expires in 2 weeks, 2 months, or some other time frame. For example, if we had consultants that we knew were only going to be with us for a couple months. IAM also enables EC2 roles, allowing individual EC2 instances to assume roles that we've set up ahead of time. It is a recent addition to AWS, and some services such as S3 have legacy access control as well. IAM allows for centralized resource control, revocable accounts, organized into hierarchies, with fine-grained access control. It's secure by default, meaning nobody gets access to anything unless you explicitly allow it. Let's look at a user example. Let's say we want to allow end-user uploads to our S3 bucket. We would first create an IAM user with access only to a particular bucket and/or path. We could then launch an EC2 server into that IAM user role, and applications inside of that server would be able to write to the S3 bucket. We could then sign an upload form with the IAM user's credentials and give that to the user, allowing access into that S3 bucket. The benefits are we've got an extremely fine-grained access control to a very specific resource. This may not be the best example because S3 is a bit unique. It allows resource or noun level control. Most services don't allow this. IAM is broken into users and groups. A group can contain multiple users, and users can belong to many groups. Before we talk about IAM though, let's make sure we understand that a master account is unique. This account is created when you first sign up with AWS. You can use this master account, for instance, to create 3 groups. Here we've created a database administrators group, a developers group, and a networking group. And then we add several users to each of these groups. The DBA group could have access, for example, to DynamoDB and SimpleDB. The developer group may be able to spin up EC2 instances, and the networking group perhaps could control Route 53. We see here that Christian is a very important person in our company, and he belongs to all 3 groups. Whereas Victor and Sean are only in the developer group, only Nate is in the DBA group, and only Brian, in addition to Christian, is in the networking group. Notice we can also have applications in these groups. Each of these users has their own individual set of keys for logging to the console and for signing API requests. Christian's keys are actually the same in each instance here. IAM users can create other IAM users, but the grantor permissions have to be greater than that of the grantees. A grantor cannot give any permissions that they themselves do not have. IAM also has users and resources. Users have access permissions, and resources have access permissions. The access to a resource is only allowed if either one or the other contains an explicit allow. If we look here at Christian only, we've given him the ability to do anything in DynamoDB and RDS. This is a bit duplicated, but we've also done that on the resource side. We've said in DynamoDB, Christian can do anything, and in RDS, Christian can do anything. This is a bit redundant putting it in both places, because really the only important thing is that one contains an allow, and neither contains an explicit deny. IAM policies are JSON documents. There's also a policy generator available, which helps assist in the creation of these documents. For most services, IAM controls the verbs rather than the nouns, or the actions rather than the resources. Inside of the policy, you can specify conditionals, such as IP address, a certain start or stop date, the time of day, HTTPS required, and so forth. It's secure by default. It requires an explicit allow be present in the policy. If we look more closely at this isn't an actual policy. This is a bit more of a pseudo policy, but I've simplified it here so you can understand the gist of it. The action allows the verbs read, write, and list. These are actions you can perform. The resource is DynamoDB. The condition in this case has to be that the date is less than this date. This could be the end time that we know a contractor is going to stop being with us, and we want to explicitly deny him access after this point. Down here, we've also given the ability on a specific resource, an S3 bucket, and especially an S3 bucket with a prefix on it, so that this user can list the objects and create objects inside of it. Again, when we talk about verbs versus nouns, we're talking about uploading a verb to an S3 bucket, customer uploads, which is a noun. These are also known as actions and resources, or what Amazon commonly refers to as Amazon Resource Names, or ARNs. ARN, or Noun Level Integration, is supported for Route 53. We can specify specific record types. In S3 for specific buckets and path prefixes. In SNS for specific topics. In SQS for specific queues, or in SimpleDB for specific tables. This is actively being added to by AWS, and I'd expect that more resource-level control is added for more services in the future. When we talk about IAM accounts, we're also talking about the ability to log into the console. A master account can certainly log into the console, and they have a login that looks like this. An IAM account also has a login. Note the differences here. In the IAM account case, we're specifically saying that this is an IAM user, and we're allowing the user to log in for a specific URL. Logging in with the master account is akin to logging in as root on a Linux server. Be very careful logging in with the master account. The console login can also be controlled by expiring STS credentials or use MFA or multi-factor authentication. The multi-part of multi-factor authentication is not only what you typically know, such as a password, but also what you have, in this case a key fob with a number that rotates periodically. When we lock a specific service's API call down to MFA, we're saying that the user has to punch in this special code in order to authenticate. Multi-factor authentication is optional. It's only $13 per fob to buy the key fobs, and every single API can require MFA. For example, we could require MFA on create or delete of EC2 instances, but allow standard credentials on all other. There's also a virtual MFA for Android and iOS, which is free. Another aspect of IAM is the Security Token Service, or STS. This is a bit similar to Kerberos in that it gives expiring access to AWS resources. The access can be from about 15 minutes to 36 hours. Auto-renewing of these keys is also possible, and it can also require MFA. This can be used for both API and console access, and it can be revoked on demand. If you want to learn more about STS, this is a great place to start. EC2 roles let EC2 instances inherit permissions, avoiding the need to copy sensitive credentials into the EC2 instance itself. You can also specify automated rotation of the access keys, which is done at 5 times a day and configurable. A typical usage here would be to create an IAM role, include the role as an optional parameter at instance launch, and then from the instance, you sign requests to services with this role's access key. IAM does have limitations, but price isn't one of them. Pricing for IAM is completely free. It also comes with free or cheap MFA. It does, however, have a 5,000 permanent IAM user account limit, but you can create a limitless number of federated accounts. IAM allows for only 250 roles per account. This is a soft limit and it can be raised by contacting AWS and asking for it to be raised. The tokens in STS will expire from 15 minutes to 36 hours, and there's no limit to the number of roles a user or an EC2 can assume. Some of the best practices in IAM are first to create a root IAM user, and then never use your master account again. You could copy your master credentials onto a USB and put that in a safe somewhere to make sure you never lose it. It's good also to create conditional start and stop accounts for consultants when you know that they'll be with you and when they'll leave. It's important to leverage expiring accounts wherever possible, which have no limit to the number of users. It's good to use EC2 rules for great security inside of your instances. You can provision by access type, in which case you would have a DBAs group that allows for Dynamo and RDS access for specific users, and perhaps EC2 for developers. Another good practice is to provision your overall master accounts by environment. Create a separate account for production, dev, and test. For more best practices, this is a great URL to visit. In summary, IAM controls access to AWS resources and the console. It applies mainly to verbs rather than nouns. Each IAM user has their own credentials, and IAM can provide long or short-term access. It enables EC2 roles, and it's a fairly recent addition to AWS. Keep checking in for evolution inside of IAM for expanding feature and service support.